Lunar Crater Radio Telescope, prototype 020A. After prototype 19, I cut down the central shaft, drilled a few more holes in it, and installed the lift wires. Here I'm also drilling holes into the shaft and into the reflector plate. I'm attaching the pulleys to the central shaft, drilling one more hole so that I can have a platform on which to rest the mock-up of the feed antenna. Here I'm cutting a piece of styrofoam plate to use as a shield in between the pulleys and the mesh to prevent the mesh from getting stuck in the pulleys. This is a complicated endeavor. I've got a checklist for assembly and for installation and for deployment operations. The mesh of the reflector dish, half of it is a white mosquito net. The other half is a green mosquito net. I tried to get matching ones, couldn't find them both on the internet in the same make and model. The mosquito net has a wire in it that we removed, and with the help of an assistant, we're cutting the mosquito net down the center along the seam. This particular make and model of mosquito net actually comes in a hemisphere, a semicircle, half of a circle, going to a central point. Here we're going to cut all the way to the center and then cut off that central point.
If you want to cut off any more, then you can do that.
Yeah, let's cut off the knob.
The hole in the middle of the mosquito net, the hole in the middle of the reflector dish, will be filled with a shaft that we saw in the previous version. Here are the green mosquito net and the white mosquito net laid on top of each other so that we can sew them together. We use pins first to pin them together, and then needle and thread with a running stitch. My living room was barely big enough for half of the mesh. Here I am using the running stitch to go through the rest of the mosquito net. And now I'm applying gray tape around the center to prevent fraying and to keep the central shaft from causing problems in contact with the mosquito net. This also reinforces the mesh at the very center. This support structure needs another hole in it so that we can run lift wires through it. Now here's the assembly from prototype 019 with the additional hole at the bottom for the lift wires to come out that central hole. I also drilled a hole on this side to allow tent stakes to hold these things to the floor of the crater at the JSC Rock Yard. Each of the eight corners of the mesh have reinforcing gray tape that not only marks their locations, but also provides some structural support. This is a big three-dimensional puzzle. The lift wires Need to go through that new hole in the shaft and then through the hole in the support structure as well. Each lift wire is labeled east, west, north, and south to make it easier to manipulate these things at the rock yard when I'm deploying the antenna. The nylon lift wires move relatively smoothly through the PVC pipe. Now I'm putting the lift wires through the reflector dish and the deployment plate, and now through the hole in the support structure. As you can see, the central shaft will go through the hole in the reflector dish mesh, through the hole in the deployment dish, through the hole in the support structure, and the lift wires will go out through the hole in the side hole in the support structure.
Here's prototype 20 and it's almost ready for flight condition. We have the feed antenna mock-up on top of the shaft, supported by 2 zip ties. You can see the feed wires north, south, east, and west leading from the feed antenna through holes in the shaft, down through the shaft. They go down through the shaft, through the center of the reflector mock-up, through the deployment dish. You can see the shaft goes down through the deployment dish, into the support structure 2x4, out through a hole in the 2x4, and out to the lift wire reeling adapters, which are right here for reeling in the lift wires.
All blue tape that you saw on the mock-up was removed before flight. Here I'm installing the tent stakes at the various 8 corners of the JSC Rock Yard. Prototype 020 lands at the JSC Rock Yard. Deploying the lift wires from the central structure up to the crater's edge. With tent stakes. Now we can see all 4 lift wires are attached to the central structure and to the feed antenna, represented all in bright pink. Bright pink was chosen to contrast with the shade of the crater at the lift yard. Now, in this sped up portion of the video, I'm installing the yellow lift wires for the deployment of the reflector dish. These lift wires go between the pulleys in the central structure up to the pulleys at the 8 corners of the JSC Rock Yard large crater.
For the feed antenna mock-up to raise up above the rest of the system, it has to be pulled by the pink lift wires. And the pink lift wires go from the central structure out to pulleys at the outside of the crater. The lift wires return from the pulleys into these 4 holes in the central shaft. The lift wires go down the central shaft to the bottom of the shaft, out through a hole in the bottom there. There is too much friction in the system to apply enough force to lift the feed antenna off of the structure. So, prototype 0200 seems to have failed in deploying the feed antenna. I'm going to remove the feed antenna and its lift wires, and I will try to deploy the reflector dish for 0200.
It's good to be flexible in this operation.
With the feed antenna removed, you can much more clearly see the arrangement of pulleys in the reflector dish deployment system. Twisting in the lift wire pair up to the pulley and back is causing friction in the lines. That may be what happened with the lift of the feed antenna. In a future design iteration, I might be able to prevent that twisting by putting a flat plate on the ground for holding the pulley in a fixed position. Each of the 8 corners of the reflector dish is marked and reinforced with a piece of gray tape. The next assembly task is to attach the gray tape corners to each of the outgoing lift wires. Even with the lines all straightened out and the pulleys operating the way they're supposed to, there's still too much friction in the system for smooth operation.